Welcome to ePathasala lecture series on computer science content for PG postgraduate courses. Here we are discussing on the paper Cryptography and Network Security. Today we are going to discuss about the need for security in networks. The overview of this talk where we are going to discuss about what are the network layer and also what is the OSI model and also the security vulnerabilities related with the OSI model, and we are going to highlight the important threats to the network DOS and DDoS, denial of service and distributed denial of service attacks. The OSI model, open standard interconnection layer, where your network is functioning based on these 7 layers. Here we have from bottom to top, it is numbered as 1, 2, 3, 4, 5, 6, 7. Totally there are 7 layers. Every computing device is functioning based on this 7 layers. As OSI model is a theoretical model where it is going to be for the study purpose of computer network, but most of the computer they use the TCP IP model, that is transmission control protocol / internet protocol model for the implementation purpose. But overall we need to understand the 7 layer functionality and their security vulnerabilities related with the implementation with respect to our network security. So when you are looking into the layers, where you can able to see 1, 2, 3, 4 from the bottom, they are mentioning about the transport services, and 5, 6, 7 are coming under your upper layer services. In TCP model, these 7, 6, 5 layer, that is 7th layer, 6th layer and 5th layer, they all 3 put together we call that is an application layer. So that is in the case of your TCP IP model, but now as highlighted here we have some green and yellow and pink color. These are the major areas where we are going to understand the importance of your security. So here we can able to see that in the case of your physical layer, first we need to understand the functionality of each and every layer. The physical layer, it is a bit stream. As a normal user, we start from the application layer, then we go layer by layer and we reach the physical layer and we will start reaching our destination. Each and every internet related application where we go for an online transaction or email related activity or anything related with your web browsing, as an end user we start with our upper layer, that is your 7th layer called application layer. So in this layer we mention about the message format and the human computer interfaces. For example, I am going to use email client, then I need to depend on this application layer. If I want to access a website, then I have to use a browser which is also functioning on the application layer. So that is why it is mentioned here as human machine interface, where each and every end user is going to be interacting with the computer with the help of this application layer. The next comes our presentation layer, where you can able to see that here whenever a message format is given by a particular application layer, it is going to be coding into ones and zeros, and addition to that there is some kind of an encryption and compression, and here they will check for the syntax and semantic of the particular message format. The session layer, where the authentication, permission and session, these are going to be maintained in the session layer. These 3 layers put together functioning as a single layer for the implementation purpose. So session layer will take care of authentication and permission related to what are the activities, and also session restoration, that means that session timeout and session management, everything is going to be taken care by this session layer. So now we can able to understand these are combinedly working as single layer in the case of your TCP IP model. Now comes a very important layer called a transport layer, which will be taking care of your end-to-end error control. That means it is taking care of the connection between the 2 machine, either it may be a client on the server. So how they are going to establish a session, how they are going to maintain the connectivity, that is end-to-end connection between the, in addition to that it is also supporting the error control. The network layer is very important function is routing, how a packet can be routed from one source to the different destination or from the destination how it is get back to the source. Everything is taken care by this layer called network layer. So here it is major role where it is mentioned as network addressing, routing or switching concepts are going to be majorly depends on the network layer. And data link layer where that is a second layer, and it's also very important to the end user machine, because each and every end users, they depends on what technology they are using. It is purely depends upon this particular layer called data link layer. So here it is considering of error detection, flow control, and this flow control mechanism is going helping the flow of data over the network. Then final layer, it's a lowermost layer of your network, is going to be your physical layer, where it is converting all your zeros and ones, that is your binary values, in your bit stream, and it is putting in the physical medium where it is going to be representing that how we can understand which is 1, which is 0. That is going to be done with the help of your physical layer. Now why I want to know about this particular layer, why I want to know about this functionality of each and every layer, because this is going to be creating some kind of connection between your server and the client, but it is not giving any proper security mechanism. Actually these layer models are designed only for providing communication, not with respect to the security point of view. So we need to understand how I can overcome the security flaws that may happen if these layers are going to be taken part in during the communication. So that is what we need to understand with respect to our OSI layer model. OSI versus the TCP IP model, as I have mentioned, where the TCP model has only 4 layers, as we have network access layer, internet layer, transport layer and the application layer. So this is what our TCP IP model. When compared to our OSI model, we have 7 layers, and as I mentioned here, it is mapping the 3 layers to the application layer, that is application, session and presentation are put together called one single layer called application layer, and transport layer is directly mapped with your transport layer of your TCP IP model, and network data link and physical layers are going to be mapped with the help of your network is renamed as your internet layer, and data link and physical are combinedly called as network access layer. And also we understood the functionality of each and every layer. Here it is providing the service and data formatting and control conversion session, everything is maintained here by this application layer. So some of the example we can able to understand here, FTP service, or if you want to mention representing your data format as ANSI, that is done directly by the transport layers application layer, transport models application layer. And here this is what happening with your transport layer, where fragmentation, sequence of data, reliability of data, error recovery, flow control, multiplexing, everything is the functionality of transport layer. Directly it is taking care control of your 2 protocols in your transport layer called TCP and UDP. And your network layer is end-to-end delivery, that is I mentioned as routing is an end-to-end delivery, logical addressing, fragments for MTU and then routing, everything is going to be taken care by your internet layer. Here we have some of the protocols called IP, ARP, ICMP, that is internet protocol, address resolution protocol, internet control messaging protocol. Then data link layer, the two lowermost layer, that is data link physical layer, is combinedly done by network access layer. We already know about these 2 layers. Data link layer is responsibility for physical addressing, error detection, acknowledgement, packet fragment and trailer bridging, everything is done by your data link layer. And here physical layer is representing the medium what is going to be used for transmitting, and also transmission method, signal strength topology, everything is going to be mentioned here. So this 2 layer is mapped with your network access layer of your transport model. And whenever we are representing the network model, here there is one process called encapsulation. The encapsulation means the user data. For example, if I am taking an 5th layer, right, that means I am taking the from the top of your transport layer, transport model I told about, that are 4 layers. So 5th, if you take the user data, that is your topmost layer data, then it is going to be converted into a segment in the case of your transport layer, and again in the network layer it is going to be called as a packet, and in the second layer, that is your network access layer, is called frame and also bit stream. So these 2 we can say that network access layer, as you can able to see that the frame and bit streams are representing your network access layer, packet is with respect to your internet layer and segment is respect to your transport layer, as here it is mentioned host to host, and data is represented your application layer. So what do you mean by encapsulation? Means I am making the data to be available for the end user by adding some additional information like our postcard. Suppose I am going to send a letter to a person, I need to write the content and I have to put an envelope, then I need to forward that message to the whoever may be the recipient. I need to send the particular message. The same mechanism is happening. What is the process here? It is called encapsulation. So I will take a data, then I will put in the envelope, then I call that segment, then I will add the name and address packet, then I will be adding the pin code or additional information, then fragment, and I am going to put in the post bus bar sending the data. It's got bit stream, how it is going to be represented. So this is what we can say as an encapsulation, and each and every intermediate device along the path when it is reaching the destination, the data are going to be de-encapsulated and re-encapsulated. That means first I will be reading the bit stream, then frame content, then I will go for the packet, not the above. So all the intermediate layer up to the packet level, they can able to see the content, and also they can able to forward the particular content according to the information which is available. Then they go for re-encapsulation process. From the segment they will add the packet and also frame as well as the bit stream information. So this is what normally happening in the case of your in networking. This is what the process, how the data are going to be transmitted from the source to the destination. So normally I take a data, either any service I will take, I can take an FTP service or telnet service or SNMP service, or I can take any web browsing, anything. If I take, first my information is going to be considered as data, then the TCP IP model will take care of adding the additional information like called segment, or it can be adding the IP packet is used in the network layer, and then it is going to be adding some MAC information. It is going to be called as a frame in the data link layer, and it finally sent as a bit stream over the network. So now we understood that what is the role of each and every layer. It is time to know about, if I am going to use the OSI model or TCP model without any security support, what are the issues I will face? What are the security issues are related with each and every layer of your OSI model? Then only we can able to understand how I can protect the data, even there is a security vulnerabilities, maybe even an attacker is going to be there. We will be keep on monitoring what is going to be happening. I can protect my data from the attacker. So for that we need to understand each and every layer and what kind of security issues may happen. For example, if we start from the physical layer, if we start from the physical layer, surveillance sniffing. Sniffing means capturing that information. They started to sniff what is happening in the network. Usually we know very well the internets are not a safe zone. We can't trust our data in the internet without any security support. Generally, if you are having any particular information is going to be placed in internet, definitely without any security mechanism, definitely anyone can able to see the content, because it's an unsecured channel. So if it is an unsecured channel, then we need to understand what kind of information they can able to gather. For example, if I am taking a physical layer, they will be using a surveillance. They will be monitoring what kind of bits patterns are going to be moving around the internet. Then they can able to start gathering that information, and based on that information they can able to get their MAC and ARP information. MAC is very important unique identity for a particular machine, is called media access control. It is a physical address for any particular machine which is there available in any networking devices. It is burnt in the network device. So the MAC address or the ARP information can be sniffed in the case of your data link layer, and network layer there is a chance of knowing about the IP address without you are not going to tell anything. They can able to gather your IP address information based on the packets they are going to be capturing, and also the port sniffing is going to be there in the transport layer, and TCP session sniffing, UDP sniffing, the two important protocol of your transport layer, where you have a transmission control protocol and UDP, user datagram protocol, where the sessions between the client and the server, where they can able to sniff that particular information, and the session layer they can sniff the transport and FTP sniffing. In the presentation layer they can have the SSL and the TLS and user ID password in the case of your application layer. Like that, each and every layer they can able to gather your information. So now we are going to look into the vulnerabilities with respect to different layer. As we know very well, similar to that of OS model, here also there is a TCP IP protocol suite. There are some security problem we need to understand. The some of the attacks may happen over your network layer, which is IP attack, ICMP attack, routing attack, TCP attack, and application layer attack. So IP attack, and an attacker want to gather the IP address, they can do some kind of sniffing or spoofing of your IP address. They want to modify the content of your IP address, they want to protect themselves as the legitimate user. ICMP attack, where they can reroute your packets, some kind of error mechanism they can able to give some kind of DOS attack is one kind of way we can exploit with the help of your IP ICMP. ICMP is the protocol where there is a chance for. Routing attack is it's usually happen in the case of your routing devices, where an inappropriate or wrong routing information can be injected in the routing table, so that they can able to redirect the packet without reaching the destination. And TCP attack, where they can hijack the session and they can start impersonate a session as they are a legitimate user. And lots of application layer attack like your HTTP or FTP or SMTP, they can able to capture your username, password, and credit card information, credentials they can able to gather without even asking from us. So why it was designed in that manner? Why the security is not the component of your TCP network layer? So TCP network, TCP IP was designed for connectivity. They assume that there is no attacker in the world. When they were designing of TCP IP, they keep thinking of only one point, that they want to make the communication between two hosts. They never thought of any kind of an attacker are going to be there in the case of your network. So host implementation vulnerabilities, there are lots of bugs in the software where the attacker can, like kind of a buffer overflow attack, where they inject the packet and overflow the packet, they can buffer, they can able to enter into your sensitive code area. Some elements in the specification and were left to the implementers. So what kind of flaw there in your network layer are in the IP protocol, that is your internet protocol, which is the layer 3 of your network OSI model, is a network layer. The IP address are filled by its originating host, but there is a chance for spoofing of an IP address. So what it means that spoofing here is, if you assume that there is a server and there is a client, and here what is the scenario we can say either it is going to be an R spoofing or source routing. Can A claim it is B to the server? Yeah, definitely they can do with the help of your R spoofing. If you assume that B wants to communicate with S, but what is the chance here is A can say that I am B, that is with the help of R spoofing, and similarly how can C claim it is B to the server is again source routing, that is happening the routing level. Because the C and S are located in a different network, A, B and C are in the same network, how A can able to say that I am B with the help of R spoofing, and meanwhile how C can claim that I am B with the help of source routing, that is a kind of routing attack. So using source address for authentication, where generally we will do in the case of remote login, in the case of your remote host etc., that is going to be happening with the help of remote utilities. So there is a security flaw in the case of your IP protocol. Even a attacker can compromise and they can say that they are the legitimate user to a particular server, and they can able to enter into the server and they can able to control entire access to the particular server. Some of the other kind of way how they can able to exploit the vulnerabilities in the case of your network layer is IP fragmentation attack. So each host need to keep the fragment till all the fragments are arrived. So the IP fragments means all the packets are going to be fragmented instead of sending as a single packet. So there is a chance for an intruder can inject their own packet into the packets along with the user where it is going to be sending as a legitimate. And the other way they can do a traffic amplification attack, that is IP allows broadcast destination. So they can able to send some broadcast messages, allows a broadcast destination, then what problem it's going to be creating is going to be occupying entire resources over your network, and it is going to be amplifying the traffic over the network. And there is another kind of an attack called ping attack. We know very well the ping is the utility, network utility for checking or testing the connectivity between the end-to-end devices. So here ping flooding, suppose I want to system to be attacked, just you can able to see here, this is a vector machine where I want to flood the ping. Usually we do 4 or 5 packets. By default in Windows we have 4 packets as ping message to reply back to understand what is the connectivity issue related with your source and the destination. But here we can able to see that the attacking system is triggering a kind of program which will be sending n number of ping requests which is reaching the victim system. This is what we say as a ping attack or ping flood or ping of death, and this maybe leads to a chance of denial of service attack, DOS attack. So ICMP attack where we have no authentication in the case of your ICMP. Generally the ICMP protocol is used for checking the end-to-end connectivity. So how I can able to provide an end-to-end connectivity if suppose I want to check, actually the ping command is using the ICMP, that is internet control messaging protocol, for checking the present of a destination or the node which is present in the network for the connectivity. Here there is no specific authentication mechanism, but anyone can able to create a ping command. And also there is one message called redirecting message, that means where the people like man in the middle attack, MITM, that is man in the middle attack, are sniffing, they can take an advantage of this redirecting message where they can able to redirect their packet from the legitimate source to their machine and to the server. That means they will be acting as a middle with the help of your message called a redirecting message, and also having a ICMP destination unreachable cause the host to drop the connection, where I simply send, even though the destination is present in my network, I simply replying that the destination is unreachable, automatically every machine will start to drop the packet. So these are the things, even ICMP echo and reply also they can do some kind of modification. That is why it happened in your ICMP attack. So what is routing? As I mentioned earlier, routing is the process of finding the best path to reach the destination based on some kind of metric, and here are some kind of routing algorithm like your distance vector, link state and BGP, and we can able to see that in the case of your distance vector, announcing zero distance to all the nodes. That means it is creating a black hole traffic. So when I am announcing, because it is purely based on the metric of distance or something, when I am declaring that is going to be a lowest metric, and everybody started to believe that this is the best path to reach their destination, so that they will be creating a black hole traffic, and all the traffic will be attracted to the attacker. All the legitimate traffic, instead of going to the right path, it will be attracted to the attacker's machine, and eavesdropping is going to be taking that information based on that, do the kind of an operation. In link state, it is different from the distance vector. It is very easy to create an attack scenario with the distance vector, but it's little bit difficult in the case of your link state routing protocol, because it understands the entire topology, and also it is a fast convergence routing algorithm. Here it will go for drop the link randomly, say that the particular link is down, that way they can give some false information, based on that they can able to redirect the particular information. and also climb a direct link to any other router. It is mentioned I am the best link to any other router in the network. As I mentioned, it's a bit harder to attack than that of DV, because distance vectors are vulnerable, easy to any kind of a routing attack, but it will little bit difficult because they are making some kind of authentication before going for creating a kind of an topology or routing table. And BGP, it is a border gateway protocol where it is using an autonomous system. Autonomous system means singly administrated controlled system. So AS can be announced arbitrarily prefix value, so that they can able to create some false information with the help of arbitrary prefix value, and also sometimes they can do some alternative path instead of a correct path where they can able to do in the case of your routing attack. The next comes our network transport layer after the network layer attacks. So we have listed some of the network layer attacks like your flaws in the case of IP fragmentation, and also we have come out with some kind of spoofing, and also we had something like ping with respect to your ICMP attacks, also routing attacks. But in the case of your transport layer, it was something different. They enter with the help of their core operation itself. As all we know very well, the connection between the client and the server is a three-way handshake. So the attacker can take that advantage. It is one of the essential kind of attack, because it is one of the essential service. We cannot stop it. We can stop pinging in your network. That means I can stop the use of ICMP protocol in my network, but I can't stop the TCP connection, because it's one of the essential. So there is a kind of an flaw which may leads an attacker to create a kind of an denial of service to the particular server, that is with the help of the initialization setup, where it is going to be having a three-way handshake. So usually three-way handshake means the client first requests for the service with the help of your sync packet X. Then the server will reply back with the Y plus the acknowledge X plus 1 to indicate that I received the sync, and then the client will reply back with ACK Y plus 1 to indicate that I received the sync Y from the server. This is what the normal process before actual connection established between your server and the client for browsing or any email related activities, anything. First thing, anybody, any kind of an application, definitely they will use the TCP as one of their transport layer protocol for establishing a connection. So here it is happening is a normal way of communication between your server and the client. But what issue we face in the case of if there is an attacker, if you assume that the client is an attacker, the client initially it was a legitimate machine, the server believed and started to connection. But if you assume that there is another one scenario where there is a attacker machine entering to get into the connection with the server, first they will send a sync X. Server believes that he is a legitimate user and reply back with sync Y plus ACK X, but the client never send the ACK Y plus X. So this issue was happening. The server need to keep waiting for act Y plus 1. That means for a longer time, because it cannot close until the client close, or this scenario is going to be completed. It is unable to send that. So this is what happening. The server recognizes that client based on IP port plus Y plus 1 as the acknowledgement need to be received from the particular client. So like that it will be keep on sending. Next time it will send sync and server acknowledge, but never close the, that is it is never finishing the connection. It's like that it is keep on sending all the time. The packets are going to be accumulated at the client side. The connection is going to be open, but it is not completed, and totally the server is unable to handle the scenario. This leads to a kind of an attack called sync flow attack, that is sync flooding. Sync flooding is TCP layer or your transport layer attack. It exploits a state allocated to the server after initial sync packet. Send and sync, but do not reply the acknowledge. This is what done by the client. Server will wait for 511 seconds of acknowledge, and the queue is going to be having an incomplete connection. That means by default it is going to be 1024 connection, means it is going to be incomplete, and totally your queue is going to be full, it is unable to accept any of the requests later, and totally it is unable to handle the scenario. The other way of attack that is happening in the case of a transport layer is TCP session hijacking. How the sessions are going to be hijacked between your server and the client, and based on that how the legitimate user is going to be disconnected and the illegitimate user is going to be having the connection with the server. And there is another way where they go for poisoning the session. Hijacking is taking over the control of the session. Poisoning means simply I will send reset connection. Even though the client is having a connection with the server, I will do a tear down connection where the connection is going to be lost during the TCP attack. And finally, we have an application layer attack. We know very well application layer is most of the end user is going to be involved. Lots of applications are there, none of them having able to provide any kind of security. For example, FTP, Telnet, POP, all these are related with your application layer protocol. They don't have any security feature. Even the case of your DNS, it is an insecure where there is a chances for DNS spoofing, DNS poisoning, DNS zone transfer. Everything is going to be there in the case of your. Okay, so denial of service attack, as we know very well, it has happened due to your TCP sync flooding and a echo TCP ICMP echo which is happening, and also some kind of UDP flooding and ICMP were happening in the case of your bandwidth. So, and also I have discussed about the ping of death, where it is going to be happening unlimited ping command to the victim machine, and also there is a unused or incorrectly used TCP options are there which create a denial of service attack over the system. So, this is a simple scenario attacker where one creating the victims. So, this is the normal traffic scenario where we can able to see a server is requesting for a kind of service, and this is kind of a distributed denial of service attack where you can able to see that enormous amount of packet which is unable to handle. We can able to real time, we can able to with the help of this particular ipviking.com website. So, overall we can understand what are the issues related with your networking when I am going to use network for various services, and also we understand the what is the layer vulnerabilities, and what do you mean by spoofing, what do you mean by flooding, what do you mean by session, and also we understood what do you mean by denial of service and distributed denial of service with respect to your transport layer network model. Thank you.